All right, we left off on student page D in the last video, so we will be starting with Module 1, Lesson 5, student page E. And we're continuing to work on multiplication and division. Later on, we'll put them all together, exponents and parentheses, and multiplication and division, and addition and subtraction. But for right now, just one at a time. So we learned in the last video that addition and subtraction are done left to right. Multiplication and division are done left to right. So multiplication's not before division. Addition isn't before subtraction. It's whatever you come to, left or right. So now let's see which one of these is commutative. So Penny made 3 batches of cookies with 6 cookies per batch. So you could say 6 plus 6 plus 6, but that's the same thing as 3 times 6. So 3 batches, each batch had 6 cookies per batch. But like I said, that is the same thing as 6 plus 6 plus 6. But the shorter way to write it is 3 times 6. So that gives her 18 cookies. Amy made 6 batches of cupcakes with 3 cupcakes per batch. So 3 plus 3 plus 3 plus 3 plus 3 plus 3 would be the same thing as 6 times 3. And she has 18 cupcakes. So just as we predicted on the last video, multiplication and addition are both commutative. You can see right here, order doesn't matter. We got the same answer no matter the order. So then we would say order in, well, no. Let's first say in multiplication, order does not matter. So because order does not matter, that means multiplication is commutative. Commutative. Students always like to add an N in there, like community. It's not commutative, it's commutative, like commuting in your car. Home to school, school to home. Order doesn't matter. Drive the same miles. Okay, so let's check out division. So 2 people are sharing 4 pizzas. So we have 4 pizzas and 2 people are sharing them. So we can see each person is going to get 2 pizzas. So 4 pizzas divided by 2. 4 divided by 2 is 2 pizzas per person. And let's see if that matters when we switch the scenario. 4 people are sharing 2 pizzas. So that means 2 pizzas have to be divided 4 ways. So in this scenario, each person gets half a pizza. So 2 pizzas divided by 4 people. And we haven't really talked about this yet. We talk about it more in Module 3. But once you go into the higher level math classes, we don't use the division sign. What we do is use a fraction bar for division. So this is the same thing as this. 2 divided by 4, 2 divided by 4, but more commonly referred to as 2/4. But the division bar means, or the fraction bar means division. And then we could simplify. 2 goes into both of these. 2 is a common factor. 2 divided by 2 is 1. 4 divided by 2 is 2. So 1/2 pizza per person. So we see that when we switch the order in division, we do not get the same answer. We get answers that are reciprocals, in fact. That means you flip it. 2 is really 2 over 1, and this is 1/2. And we can see that's not anything the same. Getting 2 pizzas to yourself or getting a half a pizza, much different. So, since our answers were different, that means in division, order matters. So if you switch the order and you're not supposed to, you will get the reciprocal of the correct answer. And that also tells us, because we did not get the same answer, that division is not commutative. Because we didn't get the same answer. So we can summarize by saying addition and multiplication are commutative. Order doesn't matter. 3 times 6 is 6 times 3. 3 plus 6 is the same thing as 6 plus 3. But in division and subtraction, order does matter, so they are not commutative. Okay, so now we're just going to summarize our findings here. So when you multiply 2 numbers and reverse the order, the products, and remember product is the word for multiplication, are the same. We got 18 for both of those products on the last page. 3 times 6, 6 times 3. Here's another one from our previous notes. Quotient, we said, means division. When you divide 2 numbers and reverse the order, the quotients are not the same. Or we could say are different, whichever one you like. So one answer we got on the last page was 2, the second answer 1/2. And they are very different. Would you rather have $2 million or $500,000? Big difference there. Or 2 pizzas or half of a pizza. Okay, moving on to the next page. And I noticed on your test there's a lot of problems like this where they give it to you in words and you just translate it into a expression or equation. So solve the 2 problems below. Show your steps in your process. So the first thing you should always do is write your equation or your expression. So we have Aaron went to the store and bought 3 6-packs of soda and an additional 2 cans. So how many cans did he buy? Well, 3 times 6, and then an additional, not 2 6-packs, 2 times 6. Oh my goodness, Kim, you're losing it. Do you guys see where I'm at? I'm on the wrong problem. Oh boy, I read half of one and half of the other. I guess I shouldn't wait till nighttime to do my videos, huh? Okay, here we go. Let's start again. 3 times 6 and an additional 2 cans. So not 2 6-packs, just 2 cans. How many cans did he buy in total? So now's when I have to kick into my please excuse my dear Aunt Sally mode to decide which is first, multiplication or addition. And I can see multiplication and division come before addition and subtraction, so I do this first. 18 plus 2, 20 cans. Okay, and I messed this one up. I think I wrote the right equation. I should have kept it there, but we'll do it again. So on this one, Frank went to the store and bought 3 6-packs, so 3 times 6 of cola and an additional 2 6-packs of Diet Cola. So additional means plus, see the word add, 2 times 6. How many cans did he buy in total? So again, we have to look at, please excuse my dear Aunt Sally, all multiplication and division must be done before adding. So that means this and this must be first. Then we can add our 2 answers. So 18 here, bring down your plus sign, 12 here, and 18 plus 12 is 30 cans. I guess I should have shown that. Not everybody can do it in their head. So 10 plus 1, 30. So we're just using order of operations, and students always ask me, oh my goodness, how do we know when we're supposed to use order of operations? Every day for the rest of your life when you're in a math class. Order of operations are set in stone. You cannot switch them up. So my answer to them is always, you'll never do a math problem without following order of operations. Otherwise, you'll get the incorrect answer. Oh, I guess we already did that. So we don't have to do 3. I wrote the equation out first. I think maybe they just wanted you to do it in your head. I'm not sure. But we did it the right way. Wrote our equation or expression and then found the answer. Okay, let's practice. So we have to keep in mind, please excuse my dear Aunt Sally, every time there's multiple operations. So I go, nope, can't do this first. That's addition. It's way at the end. Oh, that means this is first right here. Because multiplication and division are done left to right. So addition's going to be very last, so that 8's just going to hang out there. Oh, yes. 4 divided by -2. 1 negative makes a negative answer, and 4 divided by 2 is -2. So that right there gives me -2. Positive divided by a negative, negative, because there's 1 negative, and 4 divided by 2 is 2, and then times 3. So as tempting as it may be, you still can't go back to the beginning. All multiplication and division have to be done before you attempt any addition and subtraction. So now my second step will be this. So again, the 8 plus just keeps coming down. And then I do a negative times a positive. 1 negative is odd number of negatives. So negative answer, 2 times 3 is 6. And finally, I get to do my addition and subtraction. Always last. So a positive 8 and a negative 6, same, add, different, subtract. That's what I do. Put in my head the minute I see addition and subtraction of sign numbers. Same, add, different, subtract. These are different, so we subtract and keep the sign of the larger, so that will be +2. Okay, let's do one more, and then you guys can shut off the video and try the last one on your own, or you can shut it off right now and try the last 2 on your own. Okay, so multiplication and division come before addition and subtraction. I am going to do this because remember what I said? Every single time for the rest of your life you see a double negative, immediately change it to positive before you do anything on the problem. So left to right, -10 divided by 2. 1 negative is an odd number of negatives, so that's -5, and then we have times 5, and then I can rewrite this last part as just +3. So double negatives first. That doesn't mean to add them, but you just turn it into a positive to simplify your equation for later. A negative times a positive, one negative, negative answer, so negative 25 plus 3. And now we're down to addition and subtraction, so we do same, add, different, subtract. These are different, so I subtract. 25 minus 3 is 22. Keep the sign of the larger. So always do your signs in a separate step, and then you'll never forget them. So with multiplication and division, you do your sign first. With addition and subtraction, you can do it first or second, as long as you remember to always keep the sign of the larger. Okay, go ahead and shut off the video and try that last one on your own. Okay, so no double negatives here. I don't need to do that, but I will start with division, going left to right through multiplication and division. I get 6 minus 2 times negative 3. Now I will tell you, of the 3, this one is by far the most missed from this group. And there's 2 reasons. So there's 2 ways you can do this problem. So how I myself do it is I go a negative times a negative, because multiplication comes first. Everybody agree? Negative times a negative, 2 negatives, even number, positive answer. So I do this. Students go, what? How'd you make that plus? Because we do multiplication first, and 2 negatives give us a positive answer. Because remember how I said think of subtraction as that? And then I get 12. Other students will say, oh, I wrote minus negative 6. And you can do that too, because minus negative 6 turns into plus 6. So if you have 6 minus negative 6 and you turned it into 6 plus 6, it just saves you a step doing it this way. A negative times a negative is positive. Sign first in multiplication and division, and then you do 2 times 3, 6. But a lot of students will bring that negative down. Even though they make this positive 6, they'll think that negative still comes down. Not true. Because a negative times a negative becomes a positive, add 6. Okie dokie. So next we're going to talk about exponents, since we haven't talked about that part of our Please Excuse Dear Aunt Sally yet. So language and exponents. So represent the exponential expression in the following ways. So write the expression in expanded form. So contrary to many students' belief, 3 to the 4th does not mean 3 times 4. It means 3 used as a factor 4 times. 3 times 3 times 3 times 3, which we're going to see is 81, which is very different than 3 times 4, 12. So that's pretty important. How do we use it in words? We say 3 to the 4th, 3 raised to the 4th power, any of those. So 3 to the 4th, 3 raised to the 4th power. What does it mean? It means 4 factors of 3, and you can see the 4 factors of 3 there. And then we can, whoops, sorry, I didn't mean to move that so fast. And the easiest way is we can do these 2 and these 2, 9 times 9, because order doesn't matter in multiplication. And then we can do it in our head. 9 times 9, 81. So we know 3 to the 4th equals 81. So let's practice on some of these. So 6 to the 2nd in expanded form means 6 times 6, not 6 times 2. And you can either say 6 to the 2nd power, or you can say 6 squared. That's the special name for the power of 2, 6 squared. Power of 3 is cubed. power of 2 is squared. But if you wrote 6 to the second power, that is absolutely correct as well. The factor language means 2. 6 to the second means 2 factors of 6. Factors are things that are multiplied, and you can see that means 2 factors of 6. And the math equation, 6 to the second is 6 times 6, 36. Okay, so follow that example and you guys do the next one. And then shut off your video and come back when you're done and we can compare answers. Okay, expanded form means to use 2 as a factor 4 times. And one very, very important thing we learn in this section is when the base, this is called the base, this is called the exponent, when the base is negative, it must remain in parentheses or it is wrong. So when you write -2 4 times, they all must be in parentheses. So if you wrote it without, put it in. So that's it in expanded form. And this would be -2. And then we need a comma to show that both the negative and the 2, because they're both in parentheses, raised to the 4th power. Because if we just write -2 without the comma, then it means this. And this answer is positive, this answer is negative. Because this answer has 4 negatives. 4 negatives equal a positive, where this one is 2 times 2 times 2 times 2, add a negative in front. So 1 negative, negative answer. That's why the -2's have to be in parentheses. And that's why you need a comma after -2 to show that whole quantity. Or you could say the quantity -2 raised to the 4th power. So one of those two to show that the 4 doesn't just go with the 2, it goes with the 2 and the negative. So these are not the same, and I will tell you, students think they are. This one means this. And it's read differently as well. It's read the opposite of 2 to the 4th power. This gives me a negative answer because there's an odd number of negatives. This gives me a positive. So writing it the wrong way is absolutely incorrect, because you get the wrong answer or wrong sign for your answer by doing that. Factor language. The quantity -2 to the 4th means 4 factors of -2. And the math equation, -2 to the 4th equals, and this one we can do by 2's as well. So we can say 2 negatives, even number, positive answer. 2 times 2 is positive 4. And then we could say 2 negatives, positive answer. 2 times 2 is 4. So we have 4 times 4, which gives us 16. Much easier than going down the line. Or you could say 4 negatives is a positive, so put your positive there, and then you could go 2 times 2 is 4, times 2 is 8, times 2 is 16, and your positive is sitting there waiting for you. So whatever works for you. So it's kind of fun stuff, right? Okay, next do these next three. How about we do 3 and 4 together, and then you guys can do 5. Remember what I said. This is read the quantity -5 cubed, where this is read the opposite of 5 cubed. So find 5 cubed, make the answer negative. So expanded form, 5 to the third, of course, means 5 used 3 times as a factor. So 3 factors of 5. Common word name is 5 cubed. So a 3 is read cubed, and if you said 5 to the third power, absolutely fine. Factor language, 5 cubed means 3 factors of 5. In the math equation, so probably the easiest way is just to go left to right. 5 times 5 is 25, and then we have 25 times 5. I think of it as 5 quarters is $1.25. That's how I do it in my head. But if you do it on paper, 25, carry your 2, 10, 11, 12. Get 125 that way as well. That's a pretty big one to remember. You see that a lot in math, 5 to the third power, 5 cubed. So that's a good one to memorize. Then you don't have to do the work every time. Okay, next 2 are yours, and we're not going to do 6. So do 4 and 5, turn off the video, and then come back and we'll check those answers. Okay, so -5 cubed means, and the base is negative, so you must put each factor in parentheses. -5 times -5 times -5. And common word name would be -5, and then you could put a comma, or you'd say the quantity -5. I just think this is a little bit easier. -5, comma, so that means all of that cubed. If you don't put the comma in, then it means this, -5 cubed. But this means the quantity -5 cubed. Factor language, 3 factors of -5. So -5 cubed means 3 factors of -5. And -5 cubed. So first I do my sign. 1, 2, 3 negatives. That's an odd number, negative answer. And then I do the same thing we did back here. I ignore the signs. I already know the sign of my answer. So I just go down the row and do the same thing. 5 times 5 is 25. 25 times 5, we already said on the problem above, is 125. So sign first, 3 negatives, odd number and negative, negative answer. Okay, hope everybody did well on that. So this one is not read -5 cubed, it's read the opposite of 5 cubed. So in expanded form, it means 1 negative and 3 5s. So when there are no parentheses, you can't write -5, -5, -5. This negative does not go with the 3. So that only goes with the 5. So think of it as 5 cubed, then change the sign. That's what that means. And the common word name is the opposite of 5 cubed. So anytime you have a negative in front that is not in parentheses, it's read the opposite of 5 cubed. Factor language, -5 cubed means take the opposite of 3 factors of 5. Of 3 factors of 5. Three factors of 5, take the opposite. And again, we do the sign first. So 1 negative, that means there's an odd number and negative sign, so my answer is negative. 5 times 5 is 25, and 25 times 5 is 125. And there we have it. Okay, so we have 3 pages left. Let's go ahead and do, we'll just do the 3 pages on the next video because I think it's going to take 10 or 15 minutes. So we'll just stop there and I'll join you on the next video for Module 1, Goal 5, Lesson 5, Page 8. Okay, see you in a bit.